In this video we continue with the World Robotics Olympiad 2015 Elementary Challenge, and previously we built a robot for solving some of the missions, and today we continue with an improvement of this robot. And this here is the improvement. It's quite large, so let's see how it works. The robot must accomplish two missions, and the first mission is connected with these boxes. There are different colors. We have red, we have green colors, and they're on the field. So we move, we must collect them, and after we collect them we detect the color, and the color would actually, depending on the color, we must release a different number of balls from the container above. But and then we must leave the box at another place at the position at the field. So we move with the robot, we collect, and then we leave the box. You can see these two angled beams at the front of the robot, and they're very useful when you want to collect an object, because even if you are not aligned with the object, you can again collect the object like this. You can see that you always collect it. Again, if we are not aligned, we are like this, and we move, and it's a nice, smooth, and it's a very convenient way for collecting different objects. So always use these two angled beams. The second part of the competition is connected with releasing a different number of balls depending on the color that you have detected. And we've built this robot. This is the second try. We have the container for the balls above the robot, and there are some limitations for the size of the robot. It's 25 centimeters, which is about 10 inches, and we can measure with a ruler, and we can see that the whole robot is about, so it's less than 25 centimeters. It is always convenient to build a small attachment from Lego parts like this, to take a measurement of this attachment and to know that this is, for example, 24.5 centimeters or about 10 inches, and then you can use this attachment to actually measure your robot. And in this way you can keep the robot in the specified limits, here and here and above and here. And we can see that our robot, even though it is quite large, so even you probably see the whole screen with the robot, but it's less than 25 by 25 by 25 centimeters, which is less than 10 by 10 by 10 inches. Third part of the mission, let's load the container with a few balls like that. We have two balls at the right side of the robot and two balls at the left side of the robot, and we move with the robot, and then we release the balls from the back of the robot. You can see that we have two chains. These here are the chains, and these two chains are powered by a single motor, and they are connected. You can see the axles here. You can also find the instructions for building this robot below the video, but we have the motor is on the inside, and we have an axle that controls both chains. Now the chains are not aligned, and this would allow us to release only one ball at a time from both chains. So there won't be a case where both chains automatically simultaneously release a ball. It will be first one of the chain, then the other chain. Let's see this in action. I have a program. The program just moves the motor for about 120 degrees. Let's start the program with two balls. One, two, three, four. So we have 4 balls, and it's a working construction, but it has a few limitations. First, as you can hear, there's some noise when the chains are moving, and this is because some of the parts that are connected to the chains, when they move, they they touch the motor right here, this motor here. Let me just take a bean. They touch the motor right here on the inside, and that's why we hear this noise. And that's not very nice, because we have some friction between the parts and the motor when they are moving above the motor. The next, even larger problem with this construction is that it does not work for all the bows. I'll just load all the bows in the container. I've loaded all the bows in the container, and it's quite full. Now when I start the program, you'll see that the whole construction does not work as expected. Let me just start the program. And as you can see, there is even a larger friction between the bows on the inside in the container. And there's so much friction that we can't actually move the chains. Now if we release part of the friction by moving the bows by hand, the robot will start working like this. But this requires us to touch the robot with a hand, and that's not possible during competition, of course. It must be an autonomous robot. This is one of the problems with this construction. It works for a few bows, like for 10-15 bows, but when you fill the whole container with the whole 25, 6, 7 bows, it actually does not work, because there is friction between the different bows and the Lego parts, and you can't actually move and release one bow at a time, especially with this construction. But I suppose that it would be nice to use it in other competitions with other challenges, and it's very interesting because you have the two chains, and if you find a place, a competition, a mission where you are using this construction, give us a link below, record it, comment it, so that we can know it, and we can help you with making it work even better.